This is Advanced Algebra 8.1, Composition of Functions. First thing I want to do is begin by defining what it is to be a composite of two functions. So for two functions f and g, the function that maps x onto g of f of x, and whose domain is the set of all values in the domain of f, for which f of x is in the domain of g. Okay, let's break that down for a little bit. First, the operation signified by the small circle here is called the function composition, or just composition. And then this symbol is read the composite f followed by g, or the composite g following f, or the composite f then g. Basically what it means is we're going to take our function, our f of x function, and put that into our function g. But we're going to explore that first by looking at the activity that's on page 516 in your book. It says Lee Munn's car dealership offers two incentives for car buyers. First, they give a discount off of the sticker price as well as a rebate. And what we want to do is explore which is going to be a better buy for us. Do we want to take the discount first and then the rebate, or would we like to take the rebate off of our sticker price and then apply the discount? So we're going to explore that with this information. We have a rebate of $1,500 and the discount is 22%. So we're going to say that r of x equals x minus 1,500 and d of x is equal to 0.78 of x, because 22% off of something would equal in paying 78% of our price. So the first we're going to do is write an equation for the price of our car, so p of x, if we take the rebate after the discount, so r of d of x. That is the price p of x if the sticker price is x and the discount is taken first, followed by the rebate. So let's explore that a little bit down here. If I take my discount first, that would be discount is 78% of x, and then we want to subtract the $1,500 off. Part B says write an equation for q of x where we take the discount after we do the rebate. So that is the price if the rebate is taken first, followed by the discount. So if I take 78% of the price after the rebate, that would be 78x minus 1170. So if we take and find out what the difference between those two are, if I take q of x, subtract p of x, we notice that 78% of something, or 0.78x minus 1170, minus 0.78x minus 1500 gives me a difference of $330. So p of x is always $330 less than q of x. So what that means is if I take the discount first, the percentage off the sticker price, and then apply the rebate, my price will always be $330 less than if I take the rebate first and then the discount. So there's an example of using a composite of functions. When we first started exploring the concept of a function, we looked at two different ways of writing our function, and we used mapping notation and f of x notation. We're going to continue those two notations, but using it with the composite functions. So if we're going to take the function of g following f, then we would say the function g of f maps x onto g of f of x. Or we can say g following f of x is equal to g of f of x. So composite of functions are not commutative, therefore f of g of x is not equal to g of f of x for all functions f and g. And you will see that we found that in our discussion of the rebates and discounts. The one was always less than the other one. So let's take a look at example 2 here. We're going to let f of x equal x plus 5, and we're going to let g of x equal 2x squared. Let's take a look at this. We're going to find an expression for f following g of x. What that means is we're going to start with our function g of x first. So this is our g of x function. And we're going to insert that into our f of x. So f following g of x is the same as f of g of x, which is the same as f of 2x squared, because this is g of x is 2x squared, so I'm putting that in place of gx squared. So that is going to be 2x squared plus 5. Now to evaluate g of f of x, first add 5 to x, then square the result and multiply by 2. So in this case, we're going to take this function, f of x, and it's going in place of x over here. So g following f of x means I'm going to go g of f of x. So g of f of x is x plus 5. So now I'm going to take my x plus 5, like I showed you up here, and plug it into my 2x squared. So my new x essentially is x plus 5. So I'm going to say x plus 5 in here. So 2 times x plus 5, remember x plus 5 squared is x squared plus 10x plus 25. And now I have to distribute my 2, so now I get 2x squared plus 20x plus 50. So it's clear these two are not the same results, so that means it is not commutative. Throughout this course we've been studying functions, and we've been looking at the domain of all of our functions. So let's explore the function of composite, or the domain of composite functions. The domain can include only those values of x for which the first function is defined and that are paired with the values that are in the domain of the second function. So what that means is we need to look at our limitations in the first functions. In this case, I know that I can have a set of all real numbers. But my second function here is 1 over x, and we know that 0 cannot be in the domain, so we know that if I do a composite, then I know I have a limitation that that my function cannot have a 0. My value for x cannot be 0. So what I'm going to do is I'm going to set this up. The composite of t following g, this is the same as t of g of x. So that means I'm going to take my g of x and I'm going to plug it in place of x in my t of x function. So that means it looks like 1 over x squared minus 100. And I know that I cannot have that equaling 0. So I'm going to solve for x. So I'm going to move this over to the other side, my 100 over to the other side, so x squared cannot equal 100. So that means x cannot equal a plus or minus 10.